Welcome to discussion 26. We'll be talking about section 4.9 on antiderivatives today. And in this video, we will do a bunch of antiderivative examples. So we are going to look at problem 1 from worksheet 13, where we find the general antiderivatives of the functions below. I want to first have you try parts A, B, C, D, E, and G for about 7 minutes. So pause the video in 4, 3, 2, 1, pause it and try those for 7 minutes. Alrighty, so hopefully you did that. Hopefully you paused them and tried them for about 7 minutes. If not, definitely do that. Antiderivative questions in general are less systematic than derivative questions. So it takes more practice getting comfortable recognizing when do I do what? When do I use which rule? All right, let's talk about it together now. So for part A, remember my notation for a general antiderivative is we write this integral symbol, and then we have our function. And then I write this dx, which is a notational thing. It's kind of like when we write dx for a derivative. The dx here tells us, oh, the x is the variable in this function. All right, so when we do this antiderivative, we will get capital F of x. Notice also typically the convention is for antiderivatives, we write capital letters. That's why I'm calling this capital F of x. Okay, so for 4x cubed, the 4 is a constant. That's multiplying x cubed, so that'll stay there. And then that'll multiply the antiderivative of x to the third. So remember, I'll put a bullet point here. The antiderivative of x to the n dx, this is using reverse power rule. I add 1 to the power to get x to the n plus 1, and then I divide by that new power. And of course, I got to put a plus c because this is a general antiderivative, where c is a constant. So this is the case when n is not equal to -1. If we do have x to the -1 power, well, that function is just 1 over x. And we've seen in lecture that the general antiderivative there is ln of absolute value of x. And then I got to put a plus c for my constant. Okay, so using the reverse power rule on x to the third, we will get x to the fourth, and then divide by the new power of the 4. Also doing it on 8x, we'll get 8 times, add 1 to the power to get x squared, and then divide by the new power, divide by 2. And then, what's the antiderivative of 3? Well, it would be 3x. So I get a minus 3x. Got to put a plus c. And if I simplify, I get capital F of x equals x to the 4 plus 4x squared minus 3x plus c. And that is our antiderivative. So as we do more practice problems, I will start to just do this reverse power rule all together. Instead of doing 4 times this and then simplify, I will just do it all together as we get more comfortable. Okay, so I can check that this is my antiderivative. And the way I check is I just take the derivative of what I got and see if it's the original function. So the derivative of what I just got. So for x to the 4, that's 4x cubed. For the next term, that's plus 8x. For the next term, it's minus 3. And the c, the derivative, is 0. And that is the original function, so check mark, this is right. All right, let's do part B. B wants antiderivative of this next function. Okay, so capital F of x. So I will get 2 times the antiderivative of e to the x, which is e to the x. E to the x plus, oh, sorry. Now I need to do the antiderivative of minus sign, and that is plus cosine, because the derivative of plus cosine is negative sign. And the antiderivative of secant squared is tangent, because the derivative of tangent is secant squared. And I put a plus c, and that is my answer. All right, so we're moving on to part C. Okay, so for C, I have to do an antiderivative involving this square root function. So this time I haven't written an integral here. I've just written the original function. So before I do this antiderivative, let's simplify this. I can rewrite this first fraction as 2x to the -1/2. The next term becomes 3x to the 1/2. And then plus 4. Now we're ready to do the antiderivative, which I'll call capital F of x. So we do some reverse power rule. So we'll get 2 times, add 1 to the power, x to the 1/2, divide by that new power, 1/2. For the next term, I get plus 3 times reverse power rule, x to the add 1 to the power, 3/2, divide by the new power, 3/2. And then antiderivative of 4 is going to be 4x. And then I get my plus c, because it's a general antiderivative. And I can simplify. When I divide by a fraction, like a half, That's the same as multiplying by the reciprocal. So multiplying by 2, which gives me 4x to the 1/2. For the next term, that will give me plus 2, because the 3's will cancel, 2x to the 3/2 plus 4x plus c, and that is our answer. Alrighty, so let's do part D. Okay, so in D, I have two functions divided. So what we've seen in lecture is to handle these, at least right now, we need to simplify these to a sum or a difference. Because I know how to handle antiderivatives of just things plus other things or things minus other things. So the way I can do that is, let me rewrite this as 2u to the 1/2, and then split it up into two fractions. So this over u squared, and then minus 7u over u squared. Because now this becomes 2u to the negative 3/2 minus 7 over u. And we know how to handle both of these. This antiderivative, capital F of u, I'll get 2 times, I do a reverse power rule, u to the, add 1 to the power, negative 1/2, and divide by the new power. And then on the next term, that's going to be a minus 7 ln of u. And then I put my plus c because it's a general antiderivative. So if I simplify, we get f of u equals, we'll get negative 4. And if I simplify it fully, let's see, well actually no, let me just keep it negative 4 u to the negative 1/2 minus 7 ln of u, absolute value of u, plus c. That is it, that's my answer. All right, we're on to part E. Okay, we have this function e squared plus 3t squared minus 2e to the 3t. So first I want to notice that e squared is just a constant. So that derivative is, it's not just going to be itself. So f of t, the antiderivative, general antiderivative. So of the e squared, that antiderivative is going to be e squared times t. Because the derivative of e squared t is just e squared. Okay, antiderivative of 3t squared, let's try to do it all in one step. That's just going to be t cubed. And for the next term, we will get minus 2 times the antiderivative e to the 3t, which is e to the 3t. It might be tempting to say, wait, isn't that just e to the 3t? But remember, when I take the derivative of e to the 3t, I do chain rule, and then a 3 is going to pop out when I do the derivative of the exponent. But I don't want that 3 to be here. So I'm going to put a divided by 3, so that when I take the derivative of this, that 3 on the bottom will cancel the 3 that pops out from the chain rule. And then plus c. Okay, so again, I'm putting this 3 on the bottom. We need to divide. We divide by 3 to cancel out what we get from chain rule. So when I do the derivative of e to the 3t over 3, what will happen is we'll get, using the chain rule, let me just rewrite that 3 on the bottom as a 1/3. 1/3 e to the stuff times the derivative of the exponent. Derivative of the exponent is 3. And now these 3's cancel and I just get e to the 3t. And that's the function that I started with. Okay, so putting that 3 on the bottom is necessary to taking this antiderivative of e to the 3t. Okay, but this is my answer. That is my antiderivative. All right, so let's end this video with part G. So this one's trickier. We have f of x equals 1 minus 3x squared over x squared plus 1. So again, I have something like a function divided by a function, and we don't know how to handle this as it is, but our strategy was we want to be able to simplify this to a sum of things or a difference of things that we can handle. Okay, so I'm going to do this one way first. So attempt 1 is, we've seen that with a fraction, sometimes we can split it up. So what if I split this up? I would get 1 over the whole denominator. And then we'd get minus, and then 3x squared over that whole denominator. And then we'd have to do the antiderivative of each of these pieces. So the first piece we could handle. We know, hopefully, what the antiderivative of 1 over x squared plus 1 is. It's arctan of x. But the second thing, 3x squared over x squared plus 1, this we cannot handle. At least we don't know what this antiderivative is. Just by looking at it, we'd have to further simplify this somehow. So I'm going to stop attempt 1 here, and I'm going to try to do this differently. I'll call this attempt 2. And attempt 2 is going to really go back into our algebra toolkit. To simplify stuff like this, sometimes we can do polynomial long division. So long division with polynomials, I got to think back for this. All right, so the function that we have on the top, I'm going to write it from biggest power to lowest power order. So I'll have negative 3x squared. I'll also write 0x, and then I'll put the plus 1, and then divided by x squared plus 1. Okay, so what I have to do with long division is ask myself, okay, what would I multiply x squared plus 1 by? So that after I do the multiplication, one of the terms will perfectly match up with this first term, negative 3x squared. So I'd have to multiply by negative 3. Okay, now I'm going to put that up here. In fact, I'm going to put it over this like term, which is the constant term at the end. I'm going to put the minus 3 here. So when I multiply negative 3 times x squared plus 1, we would get negative 3x squared, and then we get minus 3, which I'm going to line up under the constant term. And then just like regular division, now I subtract this whole thing from what I have above. And when I subtract, the x squareds go away. I will have a 0x, which is just 0. And then I'll have 1 minus negative 3, which is 4. And at this point, this minus 3 is kind of all the way at the end here. It's all matching up with the term all the way at the end, this constant term. So the 4 represents our remainder. So what this means is 1 minus 3x squared over x squared plus 1. That equals, when you divide, negative 3, and then plus the remainder 4 divided by what I was dividing by, x squared plus 1. And this is now something that we can handle. So my antiderivative is going to be the integral, indefinite integral of negative 3 plus 4 over x squared plus 1. Got to make sure to write the dx. That's an important notational thing. Okay, so capital F of x, antiderivative of negative 3, that is negative 3x. Then I'll get plus 4 times, I know how to do the antiderivative of 1 over x squared plus 1. That's going to be arctan x. Arctan x, got to put a plus c because this is a general antiderivative. And that is my answer.